Hey everybody, Dawn Zoldai here, and I'm here today with Chad Sweet, the founder and CEO of ModalAI, creators of the incredible autopilot called VOXL 2. So, hey Chad.
Hello, Don. How are you?
I'm doing great, doing great. Hey, I think most people out there probably know what an autopilot is, Chad, but for the uninitiated, can you very briefly explain what we're talking about today?
Yeah, absolutely. So in the unmanned aerial space, an autopilot is the little computer that takes some sensor data, traditionally an inertial measurement unit, fuses all that information together and allows the vehicle or aircraft to fly. So controls the motors and so forth. What we've done to advance that is offer autopilot that fuses computer vision, which then enables the aircraft to do a lot more novel and state-of-the-art things like GPS denied navigation and obstacle avoidance and so forth, which I'm sure we'll talk about a lot today.
We absolutely will. And I know we're going to be focusing on how ModalAI's autopilot enables smaller, smarter, and safer drones. And in fact, this year you did launch this second generation of your autopilot called VOXL 2. Is that right?
That's correct. Yes, VOXL 2 we worked with the Defense Innovation Unit on to bring advanced autopilot capabilities, make them available in the U.S. We have state-of-the-art technology that uses a Qualcomm QRB5165 processor that has 15 TOPS of neural network processing and can consume 6 image sensors worth of data.
Very cool. And I think we have a quick video to show about this.
Introducing VOXL 2, the smallest, smartest Blue UAS Framework autopilot at 16 grams. Enable smaller, smarter, and safer drones and robots with VOXL 2. To learn more about VOXL 2, visit modalai.com/voxel-2.
All right, short and sweet. I want to break that down, Chad, and I want to first talk about smaller. So how big are kind of competitor autopilots that are on the market in comparison to what we see here with the VOXL 2?
So where we really bring the advancements is the integration of a lot of capabilities into a single PCB. And so in this case, I can show you that here's a business card with VOXL 2. I'm not sure if it's quite that
Oh my
easy
gosh,
to see, but
it's smaller than a business card?
That's right, significantly smaller than a business card. So traditionally, you would have a lot of components that were very, separate. You'd have a video transmitter, you'd have your maybe your payload systems and your radio control systems and your video encoding, all separate components. What we do by leveraging the capabilities of the smartphone industry is pack this all into one small 16-gram package, which really helps advance the capabilities of these next generation UAS. I think people are very comfortable with what you can do by just traditional RC, but of course our role in the industry is to advance those capabilities in autonomy and beyond visual line of sight, as well as advanced processing for mission critical applications.
Yeah, so you mentioned 16 grams, and is that like lighter than a golf ball or something? Like, what's a good
What would that? Oh, good question. Is it what a AA battery? It's about that. I think it's about the weight of a AA battery, something like that.
Really? Oh my
light,
gosh. All right, and I think we have another short video to dive a little bit deeper into the smaller aspect here.
VOXL 2 helps the smallest, fully autonomous drones take flight. At only 16 grams and less than 10 watts, VOXL 2 is designed with the lowest SWAP for extreme AI computing.
All right, there was an acronym used in that video, Chad, and being former military, I'm very sensitive to acronyms. So it was SWAP. Can you tell everybody what that means?
Sure. Size, weight, and power. That is the big topic when designing anything that needs to fight gravity, right? So these aircraft, all the energy goes to getting off the ground. And so weight is the dominant one, and then size, of course, drives weight. In terms of if you have big components, you need a bigger drone, which are bigger UAS, which needs bigger everything. So bigger batteries, bigger everything, and it becomes a compounding effect. So we want to be, we want to be the smallest and smartest part of that unmanned aerial vehicle. And so we can power aircraft from under 200 grams. This aircraft here can fly for 37 minutes and weighs only about 200 grams or so, 210 grams, all the way up to, heavy lift, right? It's easy to go big. So, we try to focus on having all this capability small. And believe it or not, we do get that. It's like, oh, well, can you, does this work on larger aircraft? Well, yeah, of course it does. That we emphasize the small because that's where all the energy needs to go to, so your aircraft's not burning all the energy. And so this has, neural processing unit built in there, a graphics processing unit or a GPU, all built in, combined with the CPU. And so a lot of capabilities made available into a tiny package.
Well, as you say, it's a lot packed into that tiny package. And, so tell me a little bit about the smarter aspect. I mean, you just started alluding to it, but let's get into detail. Maybe we'll kick it off with this little video here.
VOXL 2 enables the smartest drones. VOXL 2 is powered by the Qualcomm QRB5165. With clock synchronized image sensors, VOXL 2 enables GPS denied autonomy.
All right, Chad, I think there's some things maybe you can explain here that we're seeing in this video now.
Yeah, so we've spoken a lot about the hardware, the VOXL 2 hardware. What we also offer is an open SDK, which we call the VOXL SDK. And this is an open development environment that enables things like GPS denied navigation, which you see on display here. It enables mapping, autonomous navigation, obstacle avoidance, or SLAM, another acronym for simultaneous location and mapping. In this video, what you see is the drones flying around. It's taking its visual inertial odometry, which is the foundation for GPS denied navigation, taking that visual inertial odometry, fusing it with a depth map that we're generating using a time of flight sensor from PMD. So those two information sources are fused together to create a 3D representation of the world. And that's what you see in all the colors on the display are what's called voxels, VOXL. And those voxels provide the aircraft with an understanding of its environment. From there, then we can pick a point and tell it to plan a path to that point. So then there's path planning, which gets layered in on top of that. So this is like a super complex system, and we have all the code available for you to actually go do this and go make it happen. And so this again builds up on visual inertial odometry fused with depth mapping to get under a 3D map of the world, and then path planning to navigate around those, navigate through the world without running into things. And then all at the same time, it's actually streaming from what you'd think of as maybe a payload camera. It's streaming first-person view from that payload camera. That's what you see on the left. And the bottom right is the third-person view of the little drone that I was just showing you flying around. And so this is all running on board VOXL in real time. And which we spend a lot of time optimizing those capabilities for to make it work robustly and efficiently. We spend a lot of time on efficiency in the SDK so that it can work in real time and offer a lot of value to our customers, quite frankly.
So all of that is packed into that little tiny package that you showed us that is smaller than a business card. And I don't know if you mentioned this, Chad, but there's like 5 different neural networks simultaneously running at a pretty rapid speed on this autopilot.
That is definitely one of the capabilities that we can achieve. Yeah, so there's an integrated neural processing unit, or NPU. There's a GPU, which is kind of classically what you think of as running deep learning networks. And then of course there's a CPU that kind of, central processing unit that manages it all. And so we support a popular framework called TensorFlow or TensorFlow Lite. And then we have reference implementations for how to run a number, 6, 7, 8 different popular kind of neural network and neural network frameworks. And then, yeah, we have a demo where we run we run 5 of them concurrently. We could probably do more depending on frame rate and resolution and so forth. And so that's it's to highlight, you know, the incredible capabilities that really you can pack into something this small. And so that is different from what we just showed with the, you know, the SLAM system. The neural network system then is like, well, what does this aircraft do? If it's flying around autonomously, why, you know, why do you care? And so one of the things is like, we'll go find what's in the environment and report it back. And if you see something in the environment, you know, maybe that you alert the operator, you alert the user, you know, there's all sorts of applications where that becomes very useful, as well as like fusing all that data together to build out even a more like contextually aware map.
Now you're using a lot of technical terms here, but the bottom line is this is basically kind of fueled by artificial intelligence. And, you know, just comparatively speaking, like what kind of data are we talking about, like quantities of data that this system, this tiny system can smartly kind of ingest and then also give to the user?
That's a great question. Yeah, a lot. So we'll talk about radios in a bit, but on board VOXL 2, there is 128 gigs of flash. So you can start there, and we put that there on purpose because people fill it up and use it. So a lot of video data, video's heavy. We also have customers who take the maps that are generated and just export the maps, right? That's like useful information. If you send a drone in, survey around autonomously, go point to point to point, or you're flying it manually, but you just want that 3D map to come out because that's useful information. That's you know, other type of stuff that can be done. But a lot of it, yeah, really is about collecting video. And then of course with the neural networks, somewhat decoding what's in that video in advance or helping the operator understand, reducing cognitive load on the operator to help, you know, make sense of the environment that the aircraft's flying.
Well, that also makes it safer, I imagine, which is probably a great segue to this next video to talk a little bit about the safer aspect.
VOXL 2 enables safer navigation with depth mapping for visual obstacle avoidance. Stay connected with popular point-to-point long-range radios, including MicroHard and Doodle Labs. And fly further with 4G and 5G for beyond visual line of sight.
All right, a lot there, you know, also packed into a small package of that video. But Chad, can you explain to us how VOXL 2 makes flight safer?
Yeah, so of course, building on the SLAM system, we also have more basic obstacle avoidance, obstacle detection, and then which you can fuse. Again, that code is open, fused with a PX4, which is an open source flight controller. So we have this full development environment for our customers to go integrate, you know, these capabilities that are often done with large and clunky components. They can now do them with smaller, lighter, more purpose-built components for their specific aircraft, right? And so I guess smaller helps make it safer. You're lighter. That's been some of the, you know, the FAA's kind of safety guidelines since day one, is getting it under 250 grams or keeping it under a certain weight and so forth, and how, you know, the impact of, you know, something running into something is the weight, of course, impacts all of that. So you know, obstacle avoidance, making it lighter, and then of course we support a broad set of communications capabilities. We have, you know, Wi-Fi is kind of cheap and easy. We have MicroHard and Doodle Labs point-to-point long-range radios, which are multi-kilometer radios that are used in a lot of government use cases, but a lot of industrial use cases as well. And then for really commercial type deployments for, you know, wind farm inspection, and we support 4G and 5G cellular communications, which then really your aircraft is now a node on the internet. So it is connected to the web and out there flying. And so it can go as far as the battery will take it, you know, and really as long as there's coverage. And the interesting thing about that is when you get up in the air, the coverage actually improves. So you actually, you can benefit a lot by using cellular, and that over the years has gotten easier and easier and easier. It used to be kind of hard and expensive, but now now there's, flexible data plans, and it's not that expensive, a couple bucks a month, $10 a month or something to keep the thing going. And so if you have a, very expensive UAS with very expensive payloads, you don't want to lose it because one of your other data links went down. You want to know where that thing is, and you want it uploading that data in real time at a minimum telemetry, maybe more. And so it's definitely, those radios can be a big help as well.
Yeah, absolutely. I want to take a second to just kind of focus on 5G because, I think that's something people out there are very interested in. It seems to be the future of communications. And how have you seen developers integrate 5G, and how do you see it shaping the future of the drone and robotics industry?
Well, obviously, 5G has higher throughput and lower latency. So the hallmark of every new G is faster and better latency, and hopefully more available as well. And so, interestingly, with 5G, though, with the autonomous cars and autonomous aerial vehicles and so forth, a lot of effort was actually put into these high reliability links. They even have a carve out for, these types of activities where the network can actually very specifically know that this is an unmanned system and needs high reliability bandwidth. And so as those systems become more prevalent, I think you will see a lot of freedom given to the robots, as long as they have a human in the backup that has a high, 5 nines communication link that can take over if something's going wrong. And so you see that with some of the robots being deployed today around the sidewalk kind of robots have cellular backup. But as that gets 5G gets out there, more robust, high reliability, that'll become a lot easier and a lot more capable. So 5G, I think, is really going to help advance the unmanned systems space, especially in the commercial domain. You want a lot of robots out there. You want one central command with one operator that's able to monitor reliably and safely many robots. And so, but in today's use case, this year, it's very interesting as a backup data link. It can also be a primary data link if you're doing some of these broader communication, broader outdoor asset inspection use cases. And so I think there's a lot of use today, but I think the future, is going to be very relevant and basically required.
Well, you mentioned the outdoor inspections. I imagine you're talking about beyond visual line of sight, or as we call it, BVLOS, and also probably indoors for GPS denied environments, which we had talked about a little bit earlier.
Yeah, absolutely. BVLOS. I mean, cellular is the way to go. I mean, why worry about what range of your point-to-point link is? And also that means you're carrying heavy equipment as well. If you want a point-to-point link to keep going longer and longer and longer, you're adding more hardware, more PAs, and more antennas and so forth. Whereas cellular, it stays small, tens of grams, no matter what. You're relying on the cell base stations to handle all that work for you, and and it seems to, from our experience, it works very well.
Well, and you have a wealth of experience, obviously, with your background in cellular, and I want to pivot for a second, and we've talked about smaller and smarter and safer, but I also want to talk about bluer, because for the commercial sector, we've been focusing a little bit on the commercial sector here, but your origin story, or you kind of where ModalAI really kind of came maybe into its own, was through that really cool program that Defense Innovation Unit put out called the Blue UAS Framework. And so not only are your autopilots smaller, safer, and smarter, they're also bluer, right, than maybe the competition. So I'd like to, let's play a quick video here, and then I want to dig a little bit into that.
VOXL 2 is assembled in the U.S.A. and NDAA 20 Section 848 compliant.
All right, that was real quick. But the point is, let's talk about how VOXL, and your autopilot, at least the original version, now you're on VOXL 2, became the go-to for, OEMs initially by working with DIU and that Blue UAS framework?
Yeah, we began working with DIU in 2018 and to work on what is now referred to the Blue UAS Framework 1.0. At the time, it was Group 1 components, I think. They have a better name now. But yeah, the Group 1 component project, a Group 1 UAS component project. And yeah, and so that ended up becoming VOXL Flight, that effort. And that we launched commercially or made it broadly available in end of March 2020. So right as the pandemic was going on, our PR and marketing got going at a good time or bad time, I don't know.
Yeah.
But so VOXL Flight went out, and that's been quite successful. We have hundreds of different folks who are using it in some way, shape, or form, and definitely dozens of qualified design wins where folks are taking that and building their own UAS, which is really our goal. We want them to go build and go create successful products, and hopefully we're part of the reason they're successful. And I think that's proven to be true so far. And so the program started, I think at the time there wasn't maybe quite the or I know there was not quite the regulation there was today, like the NDAA 20 and so forth. But they saw it coming, so they wanted to start hedging their bets. And then, of course, that morphed in as that NDAA became instantiated and more and more regulation came. That turned into the Blue UAS Framework 2.0, of course, which, as we've been talking about, VOXL 2 was a big part of. And so a lot of it, there's two facets to it. There's cybersecurity, which gets by far the most coverage. But I think, for anybody in this industry, the other half of it, in the roles that we're in, the supply chain security has been much harder. Cybersecurity is a part of it, but if you're really building these things, the supply chain for the last 18 months has been awful. And whether it's China or not China, everybody is struggling to source all of the components. And so bringing that closer and closer to home in the US over time is going to really bolster security. All this technology is great, but if you can't build it, who cares? That's so we spend a lot of time on supply chain, and of course everybody in the industry has, but bringing this stuff closer is only going to help and benefit the industry. And so that, from my perspective, kind of nuts and bolts, being down deep, the supply chain is really, really, really important.
Yeah, absolutely. And for those that aren't familiar with what we're talking about, Chad mentioned the NDAA. That's the National Defense Authorization Act. And in fiscal year 2020, Congress directed that the DoD, Department of Defense, would not be able to purchase or operate Chinese owned or built, drones or Chinese components. And so that's kind of what spurred the blue being in the military, the friendly, right? Blue versus red, blue-red teams, the Blue UAS program and the framework there. And as Chad said, ModalAI has been a part of that since its inception, and now as part of 2.0 as well. So very, very cool that you continue to do that. And that's why in the video we saw made in the USA being that sticker being prominent on the package there. So very, very good. And you're right, Chad. People do focus on the cybersecurity aspect. I think that got the most press, but supply chain is clearly an issue. And so it's great that you all have been working on that and that you've been so closely connected with DIU, because not only do the military and federal agencies need reliable and safe products, right, that have sources, but also the commercial sector as well, which is probably another great segue to talk a little bit about some of the market use cases, if you will, that VOXL Flight and VOXL 2 now is enabling these smaller, smarter, safer use cases. So let's talk about some of those now. And how have different OEMs been integrating VOXL to kind of advance different market sectors out there commercially?
Yeah, so I don't think we knew this going in, how diverse it would be. But
Yeah.
we have hundreds of customers doing all sorts of different things. We'll see a couple of those here in a minute, but lots of indoor asset inspection, outdoor, video processing, just video transmission. You need a flexible platform to go achieve that. You want to throw some AI in there. Those are a broad set of customers. We have a few space related customers, which is really cool, that like non-Earth, like off the planet kind of use cases. So that's those are incredible to see. And so it's just, there's a lot of demand for a very sophisticated, very powerful, lightweight computer. And so at the core, that's what we offer. But we have a broad set of software capabilities that get put on top of that in an open way. And so our customers can really go and be flexible and build their things. We had somebody build a VR glove, just
Wow.
because we had this visual inertial odometry and they wanted something they could put on a glove and track and do something interesting. That we definitely never thought of that one. So it's really because of the flexibility, because of the openness, which is very important to us. We don't, we try not to keep it to ourselves. It's a very hard way to support your customers. We want to be open and flexible. Accessible is like just a key principle for what we do. And it allows the customers to build that flexibility, or to build novel products around that flexibility.
Well, awesome. And I know we've been working together a while, Chad. I know that there was a really cool horticultural use case that is happening in Europe that you've been vaguely enabling.
Yeah. And so, this is one we've been working with since the launch, really, of VOXL flight, called Corvus drones. The little orange drone is something they built entirely on their own, but of course, built around VOXL flights, and it navigates greenhouses autonomously with, no GPS, of course. It's so it can go then survey the environment. They're taking imagery of plants along the way, which then they can feed back into their cloud system and perform analytics on the crops that are being monitored. And so their customers are indoor farms, vertical farms, vertical agriculture, or indoor agriculture. And it's great to see. Again, this is something that maybe we never really thought about, and we don't know anything about either, but it's it's great to see that they're having success deploying these systems, and it's a really fun use case to talk about. And because of course all the projections show that we're going to need to do something agriculturally to for humanity to survive into the future. So glad to be a part of it, and it's exciting to see.
Yeah, absolutely. Really interesting to learn about horticulture, and who knew GPS that greenhouses were GPS denied. Now, I think this is a different use case. I believe this is Clio, and they're Dronut. So tell us about this one.
That's right. So this drone is encased in a shroud that allows them to basically fly uninhibited. They run into things, and you can navigate tight spaces. They have an interesting design. I think they have an interesting aeronautical design or motor configuration that has, I actually don't know the details, but it's only 2 motors, and somehow they're able to generate thrust vectors in the various ways. And so that gives them some unique capabilities and allows it to be kind of this little indestructible indoor inspection drone, which is very cool.
It is really, and Dronut. I mean, you can't pick a better name than that. It's so fun, so fun. Anyway, so both of these customers obviously have incorporated a lot of autonomy into their actual drones. And, modal AI is a big part of that. So how else is modal AI making it easier for customers to accelerate autonomy?
We try to leverage, build, incorporate off of the common open source packages in this space, like PX4. We advance a lot of the PX4 flight control functionality. We use ROS and support ROS. We try to integrate those capabilities onto our platform, and then of course TensorFlow Lite, which is a big deep learning, and then we're built on top of Linux. So these are all the tools that the industry knows, at least from the software perspective, so that they can, they're not having to learn everything from scratch. And especially some, since we've had funding from Defense Innovation Unit, I think sometimes government customers expect some obscure thing that that nobody's familiar with in the world. And so I think it's actually very well appreciated that, look, these are state-of-the-art components using state-of-the-art technologies, using these open packages that people know, and it's accessible, it's not walled off, it's not a special one-off thing. It can be, used in a broad set of applications.
Yeah, and Chad, to your point, I think even the military has seen the light a little bit, going to more modular open systems architectures, and you kind of in what they're looking for. But, fun fact, everybody, I actually met Chad at the PX4 Developer Summit this year in Austin, Texas. And so it was really cool to meet you and your team and to start getting to know Modal AI and everything you're doing. And that's kind of where our journey began. But where else might you be coming up? Where might people be able to find you?
Yeah, that's great. Yeah, that was a great conference. So definitely recommend, if you're in the industry, to go to the PX4 Developer Summit. We got a lot out of it. And of course, meeting Dawn was one of those things. And we're planning on being at the AU-V-SI Exponential Show in 23 in May, and I'm sure we'll be at the PX4 Developer Summit again as well. And then we're online. We've got the web, ModalAI.com, docs.modalai.com for all the technical documentation, code.modalai.com. We have a very active forum at forum.modalai.com. And so we're out there. We try to be as accessible as possible, and really we want our customers to be successful. We're not successful if they're not successful, so it's very important to us.
Exactly. And everybody keep an eye out next year for Modal AI. They're going to continue doing great things, making drones and robots even smaller, smarter, and safer. So more to follow, but absolutely connect with Chad and Modal AI. They've got lots of ways to connect. And don't forget to connect in the chat too. If you want to meet Chad afterwards, they're going to be on standby and hopefully make some great connections here. So I think that's all she wrote. Chad, any closing comments?
Thank you very much for having me, and I look forward to hearing all the new applications that come with people building on top of VOXL.
All right, we are out here.